Hello everyone. In this video we will talk about the second principle from the solid principle, which is open closed principle, which known as OCP. Okay, the open closed principle is the second principle in the solid design principles. In the previous video we have talked about single responsibility principle, and in this video we will talk about OCP, and it is a powerful idea for building flexible and scalable software. Scalable means you can scale your project, extend your project, add new feature easily. What does that principle say? It say software entities should be open for extension, which mean you can add to it new functionalities, new functions, new features, but closed for modification. Don't go through your classes to modify, just add. This make your code scalable. This means that once a class, module, or function is written and tested, you should be able to extend its behavior. You can extend to the behavior of it without modifying its source code. You don't need to modify the code again to add or extend the behavior of your project. Why is this important? Because modifying the existing code, especially in large systems, can introduce new bugs and break features that were already working. Instead, OCP principle encourages you to design systems that grow through extension, not alteration. How can we apply this in our code? We will use abstraction layer, which can be interfaces or can be abstract classes, so that new behaviors can be added by creating new classes rather than changing existing ones. Follow this pattern like strategy, decorator, or polymorphism to support flexible and extensible architecture. We will deep dive into this principle. Here is explanation for the OCP. We will take the bad use case that violates this principle and then how to fix and follow this principle. If we have a class, its name club, whatever the club, okay, I put value inside this class, okay, public integer budget. I need to calculate the budget of different clubs, okay. If I create a new class, okay, for example club called Ahli Club, okay, inside this class I create a function calculate budget for this club, okay, and I will pass a parameter to this function, okay, object from the class club, okay, which have the value budget. In this function I make calculation to calculate the budget of related to this club, okay. I take the value of budget from this class and make some calculation for it, okay. Right now, if I need to calculate another budget for another club, I will create new function calculate سموها budget, okay, and calculate a budget with different way. Okay, what is the problem with that code? The problem with this is that we keep modifying the code every time we need to calculate the budget of another club. Okay? This also violates the single responsibility principle which we explained in the previous video. Why? Because the class now has more than one reason to change. Although the code above may work perfectly, it's not efficient. This code can work, but it's not the best practice of coding. We modify the code constantly, which may lead to bugs. What if we have to calculate for a company or an object? You need to calculate for company, not a club. Okay, so you will change here. How to fix the problem and follow the open-closed principle. This is the good use case. Okay, we have said to apply this principle by put abstract classes or interfaces. Okay, so to solve this, okay, we will create entity interface. I will have interface called entity, whatever the entity. Okay, if it is a club or object or a company or whatever. Okay, this is the generic interface. I can apply it for what I need. Okay, I will put a function, declare a function inside this interface, and calculate budget. Okay, this is the declaration of the function inside the interface. Okay, I can implement this interface on whatever I need. Okay, Ahli Club. Okay, so I will just implement entity. Okay, so it will override the function and write the implementation I need related to calculate budget for that club. Okay, another club. Okay, no problem. Sumuha club. I just will implement the entity which calculate the budget. Okay, and calculate the budget that related to this club. This can make the code scalable. In the code above, we have created generic interface called entity with a method, generic method, calculate budget. Okay, each entity, if I have another, not a club, just company, I need to calculate company budget. I will also implement the same entity and override the function with implementation I need. It is very easy to add. That's what the OCB said. Okay, open for extension. You can extend your code. Don't modify every time. Okay, each entity like Ahli, Smuha, and the company and whatever, extend the functionality of the entity interface. Now we no longer have to modify existing code. You don't need every time you want a new feature to modify your code when you create a new entity. Okay, we just extend the functionality we need and apply it directly to the new entity. This is explanation for the second principle from the solid principle, open closed principle. Thanks for watching and see you in the next video.